Good day, grade 12 STEM Galileo. The topic we're discussing today is the special theory of relativity. What do you think the meaning of that? The special theory of relativity, or special relativity for short, is a scientific theory of the relationship between space and time. This is often termed as STR theory. A special theory or relativity is based on two postulates.
Albert Einstein originally proposed this theory in the year of 1905. On the electrodynamics of moving bodies, special relativity implies consequences of mass energy, equivalence reality of similarity, length contraction, and a universal speed limit. The conventional motion of the absolute universal time is replaced by motion of a time that is dependent on the reference frame and spatial position.
For the definition of terms, relativity. In physics, relativity refers to physical theories developed by Albert Einstein that redefined concepts of space, time, matter, energy, and gravity. Special relativity. Special relativity is special because it only applies to inertial frames and does not include gravity. It is crucial for understanding high-speed particles and electromagnetic phenomena. Doppler effect. The Doppler effect, or also known as Doppler shift, is the change in the frequency, or equivalently, the period of a wave in relation to an observer who is moving relative to the source of the wave.
All the laws of physics are the same in all inertial reference frames, at rest, moving, and at constant velocity. The speed of light in a vacuum is the same for all observers regardless of the motion of the source or the observer. Example: a spaceship is traveling half of the speed of light. A flashlight attached into it and its light travels at the speed of light. Now, you are an observer, at rest. No matter how fast or slow the spaceship, the light you see remains constant.
Time dilation. The faster you move relative to someone else, the slower time passes for you. For example, if you travel in a spaceship close to the speed of light, you might age 5 years, but people on Earth age 50 years, meaning clock ticks slower in stronger gravitation field like Earth. This led to the famous twin paradox. To solve this, the formula for time dilation is t prime is equal to time over square root of 1 minus velocity raised to 2 over speed of light raised to 2. Where t means stationary observer, the t with apostrophe are called t prime is for moving observer, v for velocity while c is for the speed of light. As v approaches c, time slows dramatically. Now, let's take an example. A spaceship is traveling past Earth at speed of 0.6 on board the spaceship. A clock measures the duration of the trip as 5 years. How much time passes on Earth while the spaceship is traveling? The givens are velocity 0.6, speed of light 299,792,458 meters per second, and lastly, time 5 years. The unknown is how much time passes on Earth while the spaceship is traveling. This is the formula that we will use. Now, let's solve. Time experience on Earth is related to proper time on the spaceship. Substitute the time and velocity. Now, solve for the 0.6 square and then cancel out the c squared both numerator and denominator. Next, 1 minus 0.36 is equal to 0.64. Then square root of it is 0.8. Lastly, divide 5 by 8 and the final answer is 6.25 years. The interpretation is, so while the crew experiences 5 years, people on Earth see 6.25 years pass.
Next topic is length contraction. If an object moves close to the speed of light, its lengths along the direction of motion shrink. The faster it moves, the more it contracts. At everyday speed, the effect is too small to notice. However, the object does not squish and the contraction is only appears to outside observation. The formula of length contraction is length is equal to L sub 0 square root 1 minus velocity square over speed of light squared, where L sub 0 is proper length or length at rest. L is for observed contracted length, V is for velocity, and C is for speed of light. Let's answer this. A spaceship is moving past Earth at a speed of 8.0 c. The proper length of the space is 120 meters. What is the length of spaceship as observed by the observer on Earth? Givens are proper length is 120 meters and velocity is 0.8 c. This is the formula. Now, let's substitute the given into the formula. This is the formula. Now, let's substitute the given into the formula. Square 0.c and cancel out the c squared, both numerator and denominator. 1 minus 0.64 is equal to 0.36 and the square root of is equal to 0.6. Now 120 multiplied by 0.6. The answer is 72 meters. For the interpretation, the length of the spaceship as observed from the Earth is 72 meters.
Our next topic is relativistic velocity. Unlike in classical mechanics where you just add speeds, relativity prevents anything from exceeding the speed of light, meaning nothing can move faster than the speed of light. But at extremely high speeds or near the speed of light, nature follows Einstein's special relativity. The formula for relativistic velocity is u prime equals to u plus v over 1 plus u multiplied to v over c squared, where u prime is for velocity seen by stationary observer, u is velocity relative to moving object, and v is velocity of moving object, and c is speed of light. Now let's answer this. A spacecraft moves away from Earth at 0.75 c. Inside the spacecraft, a probe is launched forward at 0.6 c relative to the spacecraft. What is the velocity of the probe relative to the spacecraft? The givens are v is equal to 0.75 c velocity of spacecraft relative to Earth and u is equal to 0.60 c velocity of probe relative to spacecraft. For the unknown, find the u prime, and this is the formula. To solve this, substitute the givens to the formula. Simplify the numerator and the denominator. Cancel out the c squared and add 1. Next, simplify and the final answer is u prime is approximately 0.93 c speed of light.